Hello everybody, my name is Sukrika Kangura, and in this video I'm going to demonstrate advanced science capstone project where I'm going to predict the house prices. So as per the project requirement, I'm going to follow all these steps. So let's start first with the use case. So basically while predicting the house prices, so these results they could be helpful for the real estate policies. The two important questions that we are going to answer here is, can we really predict the house prices, and what are the most important deciding factors in predicting those house prices? So this dataset is downloaded from the Kaggle and can be downloaded from here. The data is in the form of CSV format and consists of 79 features. So these are all the features which I'm not going to go through, but you can have a look. So first I installed all the necessary libraries. Then coming to the third step, which is the data quality assessment. I read my training file. So from the dot head where we view the first 5 rows, I could see that we are having 5 rows and 80 columns. So the last column is that of the sale price, which is our target variable. So then by using describe all, we describe all the features. Like if they are categorical features, we come up with the mode values, which is represented by top. And if they are numerical features, then we come up with the mean and then the standard deviation and so on. So now coming for the missing entries. So while plotting for the missing entries, we come to know that our data is having 19 entries or 19 features where the entries are null. And then we are having these 4 entries where 50% of the data is missing. Looking for the categorical and numerical data distribution, we found that in our dataset we have 37 numerical features and 43 categorical features. Now this is a very important step, the skewness check, because the skewness defines the lack of symmetry in data. And if we are going to prepare our model based on the skewed data, then the results are going to be affected. This I'm going to show you in the last step, that how the results are affected. So let's perform the normality test on the numeric features first. So we could see, like these are the numeric features and this is the skewness level. And similarly, we can check the skewness of the target variable, which is our sale price, and we could see here the positive skewness, because there is a tail over here. In order to remove the skewness, we perform log transformation. So these are the results before log transformation, where we see that our data is not able to fit the normal distribution. And this is also clear from the probability plot. And if we perform the log transformation, we could see that our data is able to fit now to the normal distribution. And this is also clear from the probability plot. So now moving towards the categorical features, I pick up the neighborhood and see like there are 25 unique features in the neighborhood. To find the relationship between the neighborhood and sale price, I assign the order to each of the neighborhood, which means that higher the neighborhood order, higher the sale price mean, and these are the name of the neighborhood. So if we plot the relationship, one could see that the neighborhood plays a vital role in determining the sale price. So there is the linear relationship which can be seen. So we perform this encoding order for all the category features as we did for the neighborhood. Then we assess the quality of the data for the test set as well. So this is test set head, then describe. And in our test set also, we have 36 numeric features and 43 categorical features. So in order to explore the data, which is step 4, so we try to find the correlation between the columns. So these are the numeric features and their correlation is plotted with the sale price. To make it more clear, we try to print the top 10 numeric features and we can see this overall quality and the living area. So higher the overall quality, higher the living area, more is the price, which makes sense also. Then coming to the categorical features, what we observe that the house price also depends upon the location where the house is. It also depends upon the external quality, like which kind of material is used for its exterior. In order to visualize this relationship, these relationships, we are performing a data visualization in step 5. Here one could see that as the overall quality increases, the sale price increases. Similarly, the same holds for the neighborhood quality. And then for the living area. Here the important thing to notice is that more the living area, more is the sale price. But also we are having these 4 outliers. So 2 over here, 2 over here, which we are going to take care in the feature engineering step. Then higher the external quality, the large is the price. So now coming to the step 6, which is the feature engineering. So here we perform a number of steps, and this is the step where I spent most of my time. Here we will remove the outliers, we will remove the redundant features, add the new features, correct the data type of features, impute missing values, remove the skewness, and then in the end we will perform the one-hot encoding. So the first is removing the outliers. So after removing those 4 entries which I showed over here, these 4 entries I'm talking about, so we have removed these in this step. Then we set the target variable to the normal price of the sale price. So by normal price, I mean that we have taken the log transformation of the sale price and assigned that value to the target variable. Then we concatenate our train and test features so that the rest of the steps they can be applied on them. Now coming to removing the redundant features. So basically starting with the basement area, it consists of 3 features. So we remove all these 3 columns and we just kept total square feet of basement area because it was just the sum up. The same thing holds true for the living area and for the bathrooms as well. Here the important thing to be noticed is, like for the half bathroom, while summing them up, I have assigned them the weight 0.5. Yeah. So then we added the new features where depending upon if the house has a pool or garage or total basement or fireplace, we decided if the house is having pool, then we assign the value 1, otherwise 0, and so on. Then we corrected the data type of the features. Further, we impute the missing values. For the categorical features, we provide the top value, and for the numeric features, if the data is negatively skewed, we impute it with the mean value, and if it's positively skewed, we impute it with the median value. Then we remove the skewness. In order to remove the skewness from the features, we perform the box-cox transformation. Then we create the one-hot encoding because our models, they can't accept the strings. So we have to provide them with the numbers. For the model performance indicator, which is step 7, we have chosen 2 parameters, root mean square and R square. So here are the reasons which I have explained why these are chosen. Because for root mean square, they are having the same values for the sale price, and with the R square, we could easily see if our model is able to predict the target variable or not, depending upon the value of R square. Then we define the root mean square and R square value for Keras. Coming to the step 8, we have compared 3 different machine learning algorithms, support vector regression, lasso, which is also a kind of linear regression, and then the linear regression. And we find that among all these models, linear regression has the least mean square and the highest R square. And similarly for the deep learning algorithm, we build the sequential model of Keras. And if you see over here, that as the number of epochs increases, the root mean square for the sale price for the basic training and basic validation set, they reduces. And with Keras, we are having the root mean square value of 0.16 and R square value of 0.72, which is less than that of the linear regression. Now coming to the last step, that how the model is going to perform if we are having different feature engineering. In order to experiment that, I try to generate the skewed features and skewed target again by performing the inverse box-cox and inverse log transformation. So from the linear regression, one could see that root mean square error has become really large. And similarly for the deep learning model, which one could see that the root mean square has also become large. And even after 1,000 epochs, still we are not able to reduce the root mean square error. So now coming to the conclusions. So we are able to predict the housing prices. The results can be used for establishing new retail policies. Most of the time that we spent is in feature engineering. The results are promising good if we remove the skewness of the data. And if we keep the skewness, then the model results are going to be affected. And these notebook can be extended further to submit the results to the Kaggle because the data is downloaded as a part of the Kaggle competition. Thank you very much.